Welcome to the series of Relational Database Management System. Myself is Fatima Rafiq, Assistant Professor, Abida Namda Senior College, BCA Department. We have started with the chapter number 4, that is concurrency control. In concurrency control, we have already seen what is log-based protocol, and we have just started with timestamp. In the last lecture, we have seen what is timestamp, what is read timestamp, and what is write timestamp. Today we will be seeing what are the timestamp ordering protocol. The timestamp ordering protocol is a protocol which is used for concurrency control mechanism. It is one of the important protocol which used by the transactions for controlling the concurrency. It is used to order the transaction based on their timestamp. As we know that what is timestamps, these are nothing but the system times or some logical counter times which we will assign to the particular transactions and the transactions which contains the reading and writing operations. Let's suppose a transaction Ti issue the read Q. If transaction Ti issue the read Q, if Ts of Ti is less than write timestamp, then the read operation is cancelled and Ti is rolled back. Suppose we have a transaction T1 and we have a transaction T2. T1 transaction start at 11:30 and the writing timestamp of Q is, let's consider 11:40. Then 11:30 is less than 11:40, so the read is cancelled. We will not given a reading option because see, reading is happening at what time? It is happening at 11:30 while the another transaction is executing the write timestamp. So the writing, the updated value of the Q, it is a dirty read value. So we will not allow the transaction to read that value because it is having a higher timestamp. So the read will be cancelled. If consider the another situation, if timestamp of Ti is greater or equal to write timestamp, then the read operation is executed and our reading timestamp of Q will be updated. Let's suppose we have a transaction T1 which starts at 11:30 and it is having a writing timestamp as 11:20. Means that some transaction is there who is already updated the value of Q at 11:20. Now the another transaction comes at 11:30 and it wants to read the updated value. So at that time that reading is allowed. Why? Because this is the current value which is executed. So we can issue the write we can allow the write instruction to read instruction to read the value, read the data item value successfully. So these are two cases. In one case, if the timestamp of the particular transaction is less than the writing timestamp, we will not allow the reading because this reading is the dirty read. If the transaction is coming and it is the newer transaction which is having a greater timestamp than the transaction which is updated the write operation successfully, so at that time that reading is allowed because the value of Q is the updated value. Now these are two cases of reading. Let's consider the writing. If we have a transaction T1 which wants to write the data item Q, if Ts of Ti is less than reading timestamp of Q, then the write operation is cancelled and Ti is rolled back. So here in this case, see, Ts of Ti means what? A transaction. Let's consider we have transaction T1 which is having a timestamp as, let's consider 11:30 and the reading timestamp is like 11:40. So at that time writing of the transaction is cancelled and that particular transaction which wants the data item to be write will be rolled back. Why we want this has to be rolled back? Because the reading, the timestamp which wants to read the data item is actually doing a modifying the write operations. Like it may be the problem of phantom read, it may be the problem of unrepeatable read, where unrepeatable write, overriding, where one transaction is already executed or read the value and the another transaction is coming in and updating the value. So that reading which is already happened and the another transaction is coming and just changing the or updating the value. So inconsistency can be created in this situation, so that writing, we will not allow the writing, we will cancel the writing at that time. The writing operation will get cancelled and the transaction which wants to update the value, we will roll back it. Now next situation is if TS, a transaction, is having value less than write timestamp, then TI is writing an onto an odd dated value of Q, hence the write operation is also cancelled and TI is rolled back. This is the same situation which we saw in the previous condition. Like here again the transaction T1 comes. T1 transaction, let's consider it is having the timestamp as 11:30, but the writing timestamp is 11:40. So that 11:30 is less than 11:40. So at that time writing operation will produce some inconsistency in the transaction. So that's why we will not allow the transaction to write, we will cancel. Otherwise, if these two situations are not there, means if the transaction which wants to want to issue the writing, if it is not less than the read timestamp, if it is not less than the write timestamp, then what we can do, we can give the access to execute the write operation. Otherwise, see here, whenever there is a timestamp is less, see we already know that timestamp if is less means that transaction has to execute first. It has it, if it is having a timestamp value which is lesser than the actual execution of the transaction, actual execution of the instruction, so this situation will create the inconsistency. So we avoid all such situation by using the timestamp ordering protocol. This is the example which we have seen just now. See here, I have a transaction T1, T2 and T1 and T2. Here the reading timestamp is 11:30. Then we have another operation which is having timestamp as 11:31, 11:32, 33, 34, and then this is 35. So this write operation is cancelled and it has to be rolled back. Why? Because here writing is already happened. If the situation is there where we have a reading, for reading we need to check two conditions and for writing we need to check two conditions. But in this particular conditions, remember that whenever the transaction which require the data item to be accessed, if it is less then the reading or a writing timestamp, we always cancel it. We always cancel it, whether the transaction require reading or writing. We will not pay attention whether it was reading or writing, but we will cancel if the transaction is having lesser timestamp. So this is the timestamp ordering protocol. I hope this is clear to you. We will remaining I think only one topic is there, that is the Thomas Wright tool. It is just a variation in the timestamp ordering protocol. We will see that in the next lecture. If you have any doubt, you can write in the comment box. Thank you.